Right, so this lesson, we are continuing 7.5, Pure 2, but I broke it into two parts. So this is the second part of the lesson, which we're looking at maxima and minima. Now, just a bit of quick recap of what we did last lesson, because what we did last lesson affects what we do today, okay? First of all, what we did last lesson is learning how to put the a cos x and plus and minus b sine expression into a sine our sine x plus minus alpha, or our cos x plus minus alpha. And the shortcut that we've learned is, remember the switch, we're learning making two switch down to one. So to work out the value of r, we'll do the Pythagoras. So the shortcut is the Pythagoras, okay, using the coefficient a squared plus b squared and the square root. And for the value of alpha, we set an equation, tan alpha equals 2. If the question wants sine alpha, we'll put a matching coefficient underneath and then the other coefficient on top with no negative sign. All right, so that's what we've learned last lesson. Now we're going to apply this into today's lesson about finding maxima and minima. So first thing, express. So in this question, in this example, there are actually three questions in there. So the first question is, so that's part A, express in the form of our cos theta minus alpha. Part B, hence find the maximum value of theta plus blah, blah, and then part C, and give the smallest value of positive value of theta. This is the core concept we're learning today, these three questions. And they usually come together as well, like a meal deal. You get sandwich, you get a drink, you get snacks. So part A, B, and C, there we go. Right, part A, express 12 cos theta plus 5 sine theta in the form of our cos theta minus alpha. Now, if you remember from last lesson, I'll suggest you pause the video, have a go at this question first as a bit of starter, a bit of warm up. And then when you're ready for the answer, you can press play. Right, so here's the answer, okay? R equals 12 squared plus 5 squared square root, which is 13. Tan alpha equals to, now because they want a cos in this question, it's cos, therefore we'll put a cos coefficient 12 underneath as the denominator. So 5 over 12, arc 10, which is 22.6 degrees. So to finish off the question, we'll rewrite the question 12 cos theta plus 5 sin theta equals to R13 cos theta minus 22.6 degrees. Now from last lesson, you will know anything that we see 12 cos theta plus 5 sin theta from now on, we're not going to use this. We're going to use the new version instead. Okay, that's the whole point of last lesson. We're learning how to convert this. Right, by the way, one thing is minus in the bracket, so make sure you read the question carefully. It's a minus in there, so it's a minus in here. All right, part B, hence find the maximum value of 12 cos theta plus 5 sin theta. So we want to find the maximum value of this 13 cos theta minus 22.6 degrees. Okay, so I want to find the maximum, of 13 cos. Now remember, we're not using the 12 cos theta, we're using the 13 cos theta minus 22.6 degrees. Now, I did touch upon this concept last lesson. Why is there maximum, minimum? Why is there range of answers? Because if you have a highlighter, do it with me, right? Because of this cos theta minus 22.6 degrees. Highlight just the cos in the bracket, not the 13, okay? This value, this highlighted value has a range of answer from -1 to 1. So if we substitute, okay, so if we substitute the yellow bracket as yellow, highlighted yellow bit as -1, so if, okay, so I use a highlighted bit, equals -1, and then value equals to 13 times -1, which is -13, right? So we replace the highlighted bit by the -1. But if the highlighted part is 1, then the value equals to 13 times 1, which is 13. So now the question wants a maximum. So which is maximum? The maximum. Therefore, the max value of the whole thing of, I'll rewrite this one, of 13 cos theta minus 22.6 degrees is 13. And that's the answer. That's the maximum value of the whole thing. So sir, what about the middle values? What about, from -1 to 1, there are so many values. Why do we only substitute -1 to 1? -1 and 1. Why don't we substitute the other values? And that's because -1 and 1 are the values that bound the cos graph, the cos values. Therefore, these two, -1 and 1, are the extreme values. like the ceiling and the floor of the function. So if you think about cost graph, that's the highest you can get, and that's the minus you can get. Now, in a cost graph, normally the highest is 1. Now, but it is not always the case you substitute 1 to find a maximum. Later example, you'll see why. So therefore, it is why it's important to substitute both -1 and 1 to see which is bigger, which is smaller. If they want you to find a minimum, then your answer will be -13. If you find a maximum, this one is 13, right? So that's part B, all right? So therefore, why don't we substitute the middle values? Because the middle values will only give you answers between -13 and 13, which doesn't mean anything anyway. We want to find a maximum or the minimum. Right, part C, and give the smallest possible value of theta at which it arises. So part C. So it arises. I know it's like an English lesson, but this it, what does it refer to? This it refers to the maximum value. So when does the maximum value occur? So the max value arises, max value arises when, what's the condition? When this bracket equals 0. So when it equals 1. So we write the highlighted part, which is when cos theta minus 22.6 degree equals 1. So that's the meal deal. So it comes together like a two-way punch. The first one, they ask you for the maximum minimum, and then it asks you, so you make the yellow part equals 1, highlight the yellow part equals 1, yeah, then work it out. So that's our next math. We work out theta. So theta minus 22.6 degree equals arc cos of 1. We know arc cos of 1, so you say cos graph. So cos equals to 1 when it's 0 degree or 360 degree. So theta minus 22.6 degree equals to 0 degree or 360 degree. Add 22.6 to both answers, so 22.6 degree or 382.6 degree. The question wants the smallest positive value, so therefore smallest positive is 22.6, and that's the answer, 22.6 degree, and that's the answer, right? So we're going to repeat this very similar thing for the whole lesson. Right, next one, practice. I said practice, but we'll do maybe 1 or 2 together so you can get used to it, all right? I'll give you time to pause the video and then have a go at the question, see if you understand. Different students, when I've seen over the years, different students understand this at different stage. Some get it really early, and then some maybe need 1 example, some need 2 examples, some need 3 examples. But if you need them all as example, that's fine. You can do more as a practice in the questions. So, right, so if you understand, you can try the question A. Let's call this question A, B, C, and D. You can have a go question A, B, C, question A first, and then see if you got it correct. Okay, practice. Find a maximum value for the expression and determine the smallest possible value of theta at which it occurs. So, compared to the previous one, the example, you have skipped part A. Okay, we jump straight to part B because the expression given in the question is already like the one in part A. Okay, right. So question A. All right. Where's the yellow bracket, like the one we did in part B, previous question? So where is the range of answer? Which expression gives you a yellow bracket in this one? Question A. Okay. The yellow bracket is the sine theta. This sine theta has a range between -1 and 1. By the way, in your notes, I believe there are lots of space underneath the table. So feel free to use the space below to write your answers. I know this table doesn't have enough space for you to write down. So question A. Okay. So smallest, we want to find a maximum value. So we know sine theta has a value between -1 to 1. Okay, so if, okay, the highlighted part, you can use the word when as well instead of if. So when, okay, so when highlighted part equals to 1, or -1, doesn't matter which we'll put it, 20 sine theta will equal to 20 times 1, which is 20. Where does the 1 come from? Because we substitute sine theta as 1 anyway. But when this equals to -1, then 20 sine theta equals to 20 times -1, which is -20. Therefore, the max value equals to 20. And that's the answer, 20. Okay. And when did it arise? Okay, so Next part arises. So max arises when the highlighted part equals -1. So when, by the way, I forgot to highlight this. When sine theta equals to 1, right? So it occurs when sine theta equals 1. So therefore, theta equals arcsine of 1. So arcsine of 1 that's 90 degrees. So theta equals 90 degrees. And that's the answer. Okay, so theta equals 90 degrees. Okay, if you're happy with it, you can try part B. Okay, so I'll guide you through. So in part B, where's the highlighted bracket? Where's the highlighted expression? Which expression in part B would you highlight? All right. If you're unsure, you can use a pencil to highlight. You can use a pencil to bracket it, so you know if you don't want to mess up, because once you highlight, you can't go back. Right. So part B, the highlighted part is with different color, is the sine theta. Just the sine theta, nothing else. Not the 10, not the 5, because only sine theta itself has a range of value between 1 and -1. Now, you can pause the video, follow the structure in part A, and have a go at the question. All right. When you're ready for the answer, you can press play. I'm going to go through it. Okay. Right. So part B. So 5 minus 10 sine theta. So 5 minus 10 sine theta. We know that's the highlighted part. So step by step. When the highlighted part equals to 1, then 5 minus 10 times sine theta becomes 5 minus 10 times 1, which is -5. When that's a highlighted part. When the highlighted part equals to -1, 5 minus 10 times -1. I don't know why it's the in there. Equals, now 5 minus 10 times -1 is 15, I believe. I can't trust my mental maths. Yeah, that's right. So remember what I said, it's not always 1, it's not always to substitute 1 to give you a final maximum. In this case, the max value is 15, and that's the answer. 15. So this one, 15. And when is it right? Arises when what? When the green highlighted part equals -1. So what's the green highlighted part? When sine theta equals -1. So then we go in and solve it. Okay, so theta equals arcsine of -1. So inverse sine of -1 is -90 degrees. So that's when the calculator becomes useless. So when the sine theta equals -1, it's -90, but the question was a positive answer. So the first positive answer is here, 270 degrees. So theta equals 270 degrees. All right, so 270 degrees. I'm going to put theta equals -90 degrees, but we're not going to use it. We'll use 270 degrees instead. All right. Now, part C. If you still struggle, okay, we're going to do one more. But if you're happy with it, I would suggest you try having a go at question C. Okay, use a pencil instead of a highlighter if you're unsure. Right, part C. So yeah, I'm going to go through now. Part C. The highlighted part this time is this one. It's the cos. Okay, it's the cos in the bracket. Nothing to do with coefficient, just a cos. So question C. So when the highlighted part equals to 1, the question was 3 cos of 3 cos, well, actually, so 3, yeah, well, 3 cos theta plus 20 degrees. That's the highlighted part, wasn't it? So it becomes 3 times 1, which is 3, because we substitute the cos, the whole bracket as 1. So it equals 3. Next, when the highlighted part equals to -1, then it becomes 3 times -1, which is -3. So therefore, the max value, now the question could ask you for the mean value. So the max value in this case is 3, but if they ask for the mean value, you will put -3. So it arises when what? When does it equal 3? When the highlighted part equals 1. So when cos theta plus 20 degree equals 1. Now it's time to use the find the theta. So theta plus 20 degree equals arc cos of 1. So put in a calculator, arc cos of 1 is 0 degree. So now have to be careful. So that's 0 degree or 360 degree. Right? So theta plus 20 degree equals 0 degree or 360 degree. Now, so why do you put 360? Is it, isn't it useless to put 360? Because the first answer, because 0 is already a non-negative answer, so can't we take that? But now when we minus 20 degree, 0 minus 20 becomes negative 20, and 360 minus 20 is 340. Therefore, we don't accept negative answers in here, so 340 is the answer. Therefore, useful to write down 2 answers. Okay. Next one. Next one. Part B. Right, again, pause the video, have a go at the question. Highlight the function that give you a range of value first. I'm going to go for now. This time, the highlight part is here in denominator. Okay, so let's have a go. When the highlighted part, so question D, when the highlighted part equals 1, then the question becomes 2 over 10 plus 3 times 1. So the whole thing we highlighted becomes 1, so which equals to 2 over 10 plus 3, which is 2 over 13. When the highlighted part becomes minus 1, 2 over 10 plus 3 times minus 1 equals to 2 over 10 minus 3 is 7. Now you tell me which is bigger. First one, second one is bigger. Okay, so why? Because, well, the smaller the denominator, the bigger the fraction. Okay, the larger the value. So therefore, the max value equals to 2 over 7. Right? Arises, when it arises? It arises when the highlighted part equals minus 1. So when theta minus 30 degree equals minus 1, when we let the highlighted part equals minus 1. If you're laughing at me struggling to write on the board, yes, and a lot of students do that. Yeah, when I was a kid, I do that as well. When I see teachers struggling to write on the board, how difficult it is. Until one day maybe you become a teacher, then you understand. Anyway, so arc side and right side, so theta minus 30 degree equals inverse sine of minus 1. So inverse sine of minus 1 is when 270 degree. So and what's the one before? If you minus 360 is negative 90 degrees. So theta minus 30 degree, but that's not really needed. Or minus 90 degree. Reason I go backwards because I see theta minus 30 degree. That means you move the graph to the right by 30 degrees. Anyway, so the range sometimes may include a negative answer because you use theta minus 30 degrees. So if the original range is like this, when you take away 30, that becomes like this. So you can see that there might be a negative answer. But in this case, minus 90 plus 30 is still negative. So theta equals 300 degree or negative 6 degree, but we don't take negatives. Okay, no negatives in my life, only positives. All right. So yeah, so that's the answer. Right. So right. So if you're happy with it, or more or less understand this, maybe you can have a go at this question, have a go for A first, again, question by question. I'll help you with it. Exam practice. If you're confident, again, you can try to have a go for the full question. All right, pause the video, have a go as much as you can. If you want to check your answer at the point, just play the video. All right. Right, these are the final answers. Part A, Part B, and Part B2. Okay, check your answer. If you got it wrong, I'm going to go for it now. If you got it right, well done. Yeah, well done. That's the end of the lesson for you. So, question A, pretty straightforward. To work out value of R, we've done this numerous times, either last lesson or today. So R equals to square root of the coefficient 6 squared plus 8 squared, which is 10. And to work out alpha value, we do 10 alpha equals to the one cos. Therefore, the cos coefficient will go underneath 6, and the 8 will go on top, right? So inverse 10 of 8 over 6. So alpha equals, now the question wants you give in radians and 3 decimal places. Nothing more, nothing less. Just like I don't want pickles. No, not even one pickle in my burger. Okay, nothing more, nothing less. 3 decimal place, 0.97. Make sure you round it, because if you don't use this answer, if you don't use 0.97, it might affect your answer in part B and part B. Right? So especially modeling for this type of question, they always say 3 decimal place, 4 decimal place, 3 SF, 2 SF. Just be careful with that. All right. So that's it. Part BI. So where's the bracket for this one? Well, first of all, there's no bracket in here yet because I can see the word, not word actually. I can see this 6 cos theta plus 8 sin theta. That's the same as part A. So I've told you it's a meal deal. You have ate the sandwich. You've eaten the sandwich. Now it's time to convert them. Here's a snack. Change it first. So I can change it to P theta part P. So instead of writing P theta equals to 4 over 12. Now I'm not going to write 6 cos theta plus 8 sin theta. I'm going to write what I've got for part A, which is 10 cos theta minus 0.927. Right? Then I can start to enjoy my snack. That's my bracket between 1 and minus 1. If you struggled with that previously, have a go again now. Okay, so when that equals to 1, P of theta equals to 4 over 12 plus 10 times 1, which is 4 over 22. But when that equals to minus 1, P of theta equals to 4 over 12 plus 10 times minus 1, which is 4 over 2, which is 2. And hence 2 is definitely bigger than 4 over 22. That's the maximum, right? And part 2, find the value of theta at which the maximum occurs. Well, yes, so part C, part B2, sorry, part B2. So arises when this equals to minus 1. So we let that equals minus 1. So cos theta minus 0.927 equals minus 1. Arc cos minus 1. Arc cos of minus 1 is 180 degrees, which is pi. So theta equals pi plus 0.927. So pi, which is, I believe that's the answer, right? Yeah, so 4.07 2 decimal places. And that's the answer. Okay, and that's the end of the lesson. What you've learned today is finding maximum minimum. Now, that's very important. I'll give you a bit of a spoiler. Oh, spoiler. No one likes spoiler, but we do in maths. Can you look at this? Okay, just spoiler. This exactly what we do. Look at this question here in the beginning, and then you have to find a maximum, minimum. See, quite a classic modeling question. That's what you need to do. This part forms the first part of the modeling question. Right, and that's the end of chapter 7.5.